right, and today we're going to look at functions. So the first thing is we want to determine whether relations are functions. So you're going to be given a variation of different relations. You'll see ordered pairs, you'll see XY tables, you see these mappings. All right, so the first one we're going to look at is the ordered pairs. So here we have -3, 4, -2, 4, -1, 3, 0, 3, 1, 2, 2, 2. And we notice that a lot of the y's repeat, right? 4, 4, 3, 3, 2, 2. But the y's are the outputs. Now, it's okay if the outputs repeat. That just says one output has more than one input. Okay, but for functions, we want to make sure that each input has only one output. So if any of the x's repeat, then we know it's not a function. But here, we have -3, -2, -1, 0, 1, and 2. None of those repeats. What that means is that -3 has only one output, -2 has only one output, -1 has only one output, 0 has only one output, 1 has only one output, and 2 has only one output. So that means, yes, it's a function. Yes, because each input has exactly one output. So each x has only one y. All right. And for the next one, we have 1, 7, 2, 4, 3, 8, 1, 10, and 5, 6, and 4, 3. Okay, so 1 has only one output, 2 has only one output, 3 has only one output, 1, wait a minute, I thought I said 1 before. I did. So 1 has an output of 7 and an output of 10. Okay, so this tells us that 1 has more than one output. So no, because the input 1 has an output of 7 and 10. All right, so 1 has an output of 7 and 10. All right. And numbers. For C, we have a table here. We have the inputs and we have the outputs. 0, 0, 3, 2, 6, 4, 9, 8, 12, 16, 15, 32. Okay, and if you're not good at reading tables, it's okay. So just think of those as points, as ordered pairs. 0, 0, 3, 2, 6, 4, 9, 8, 12, 16, and 15, 32. Now, did any of those x's repeat? No. 0, 3, 6, 9, 12, 15. 0 has one output, 3 has one output, 6 has one output, 9 has one output, 12 has one output, and 15 has one output. So this one is, yes, a function. Because each input has only one output. All right. And D, here's the mappings. Okay, so here, the way you would read these is you want to look to see where the arrow is coming from and where it's going. So for the first one, this is saying 7, comma, -5. And this next one, it goes from 11 to negative 5, so that's 11 comma negative 5. And this one goes from 11 to negative 9, that's 11 comma negative 9. And here 43 goes to negative 9, 43 comma negative 9. Probably wrote it too small, sorry. All right, so did any of those inputs have more than one output? 7 only had one output. 11 had, it has two outputs, negative 5 and negative 9. So it goes to two places. Okay, so here 11 was G on the negative 5 with the negative 9. All right, so this one is not a function. Not a function because 11, the input 11 had two outputs. Negative 5 and negative 9. Right, so the mappings are an easy way to tell if you see two arrows coming out of the input, any of the inputs, boom, you know it's not a function. All right, if you only have one arrow coming out, then it is a function. All right, so the next one, determine whether the graphs represent functions. So here you'll be given graphs that look like this, maybe like this. All right, it's easy to tell, and the way you tell is the vertical line test. So you want to imagine lines. Now what you can do is you can actually draw the lines going through the graph. Okay, so you can draw infinitely many lines, vertical lines. So one, look at all those vertical lines. So the vertical line test says if any of those vertical lines crosses the graph more than once, then it's not a function. So here this line crossed only once, 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 crossed only once. Yes, this one is a function. It's a function because, and you can say because each input has one output. That's the safe bet, okay? But if you want to use the vertical line test for it, you can say no vertical line crosses the graph more than once. But technically, each input has one output, okay? So this is 1, 1, 1.5, 2, 2, 3, 3, 3, 3.5, 2, and 4, 3. All right, so a lot of repeating outputs, but no repeating input. All right, let's look at this one. B, do any of the vertical lines cross the graph more than once? If it crosses the vertex, that only crosses once, right there. This one, crosses twice. And there are multiple ones that cross twice. This crosses twice, and this crosses twice, and this crosses twice. So all of those vertical lines touch more than once. So this is no, it's not a function. And you can say many inputs have more than one output. Okay, or you can say because it failed the vertical line test, many vertical graph more than once. Alright, and now, so that's that. That's how you can tell whether a graph is a function or not. Now, how to tell whether a function, what the function's domain and range are, given the graph. Okay, so domain, those are the x values. The inputs that are included with the graph, and the range are the y values. Okay. So the domain, we want to look at the x values. So looking at these where we have just points scattered about, okay, you want to look at the x's. So what's the x here? 2. So domain is 2, 2, I'm sorry, negative 2, negative 1, 0, 1, and 2. All right. And the range are the y values. So you want to look at the y values, the y-axis. So if you go to the y-axis, boom, that's a 1. Boom, that's a 2. Boom, this is also a 2. So because these are both 2, you don't need to repeat it. So you just need to write it once, okay? So that's a 2. Boom, that's a 3. Boom, that's a 4, right? And that's the range. So for the domain, go to the x-axis. For the range, go to the y-axis. Okay. And if that doesn't make sense, look at the points. So this is negative 2 comma 1. This is negative 1 comma 2. This is 0 comma 2, 1 comma 3, and 2 comma 4. So the domain are the x values, negative 2, negative 1, 0, 1, and 2. And the range are the y values, 1, 2, 2 again, so I'll just write it once, 3, and 4. All right, and the last one, so this is one where it's continuous, right? And for the domain, we want to look for the farthest left point. Okay, the point that's farthest to the left. Okay, so farthest left. Which of these points is farthest to the left? This one. And what is that? Go to the x-axis. That's a negative 2. All right. And then you want to go the farthest right. What's our farthest right point? Right there. What does that go to? That's a 3. Okay. So we want to put the x in the middle because that's our domain. And then we're going to put a less than and a less than. And because these are both closed, right, they're shaded in. They're not open like this one. So because they're both closed, remember it's a less than or equal to. Ta-da! Just like that. That's the domain. Now the range, those are the y values, okay? So you want to look at the lowest point. Where's our lowest point? Where's our minimum? And it's right there. That's the lowest that it goes. What does that go to? 1, 2. So negative 2 again. Oh boy. then what's the highest point that it goes to? It's high, but this is higher. And that is 2. So highest point, 2. And here for the range, we're going to use y, because range is the y values. So again, less than, and because they are closed, it is less than or equal to again. Hey, and that's it. And the last problem. Identifying independent and dependent variables. So the function, you're going to be given a word problem with an equation with a function. It says the function c equals 5t plus 4 represents the cost c of t tuna cups. Alright, so we want to identify the independent and dependent variables. So the independent, that's the one where you would, if you had a XY table, okay, those are the values you would input, okay, independent, okay, those are the ones you would put into the equation when you're evaluating. So here, our independent is t. Dependent variable is t. Alright, because that's the one we're plugging in, numbers 4. And then when you plug numbers in, let's say you plug in 7, you'd put 5 times 7, which is 35, plus 4 is 39, and then you would get the c. So the c depends on what the t is. That's why it's called a dependent. Okay. So our dependent variable is c. Now it's usually whatever is equal to the function or to an expression, that's going to be your dependent, and the one that's inside of the expression, that's going to be the independent, usually. Okay? And here, the domain is 1, 2, 3, and 4. What is the range? So they gave us the domain. And remember, the domain are the x values, or in this case, the t, right? These are the independent. The inputs. All right. So we're going to plug those in for t. So we want to plug each of those. We have c equals 5, and then times 1 is our first one, plus 4. C equals 5 times 2 is our next one, plus 4. C equals 5 times 3 is our next one, plus 4. C equals 5 times 4, plus 4 is our last one. And we just solve those. So we get 5 times 1 is 5, plus 4 is 9. 5 times 2 is 10, plus 4 is 14. 5 times 3 is 15, plus 4 is 19. 5 plus 4 is 5 times 4 is 20, plus 4 is 24. And there you go. That is our range. So the range is 9, 14, 19, and 24. Oops. Fancy practice.